Okay, so this problem asks you to draw a sketch of the electromagnetic spectrum, list the regions by the type of light, and then relate that to frequency, wavelength, and energy. This is a great exercise because if you can redraw this particular sketch, then you can answer any of the questions in introductory chemistry that come along with the electromagnetic spectrum. That includes questions about energy and wavelength, energy and frequency, as well as frequency and wavelength. It also, you can answer questions about the different types of electromagnetic radiation as well. And so we put everything together in one drawing. And so let's go ahead and let's start with a squiggly line. And that squiggly line is going to represent the spectrum of light waves. And so I start off with long wavelengths, and then I move to make sure those waves get closer and closer and closer together until at the end, you can't even tell when one wave starts and the other wave begins. So let's go and let's remind ourselves what that looks like as far as wavelength is concerned, because we want to list the regions and relate that to the wavelength, the frequency, and energy. So what about wavelength? Well, is wavelength getting smaller from left to right or larger from left to right? Well, it's getting smaller from left to right. That means it must get bigger from right to left. Now, frequency, nu, is opposite of wavelength. So the frequency goes the other direction. And energy is the same relationship as frequency. And so now if someone asks you a question about a particular wavelength, you can say, is it higher or lower in frequency, or is it higher and lower in energy? So the last thing to do then is to put the different types of electromagnetic radiation on the spectrum. So what do we have with? And this is important to start with. You start with in order of increasing energy, because we've already decided that energy increases from left to right. So that means that energy is higher with shorter wavelengths. That means that energy and wavelength are inversely proportional. And that's what our arrows show at the bottom. So the first type of light is radio. Radio waves are first. Now, you don't need to know the exact frequencies and wavelengths that they occur at. You just need to know their order. So after radio comes microwaves. Then after microwave comes IR. Now, if you remember that there's IR and then there's visible, the visible spectrum goes in order, in energy order, with the mnemonic Roy, red, orange, yellow. You can barely see the yellow there. Let's get a little bit darker yellow. Yellow, green, blue, indigo, and then violet. And so that's the order of the visible spectrum. And so if you remember that the order of the visible spectrum is Roy G. Biv, then you know that the R, the IR, goes with the red. And then what comes next? It's the one that goes with the violet. So it's UV. Then after UV is X-ray. And then the last one, the highest energy, is gamma. So if you can reproduce this chart with the different types of electromagnetic radiation, these are our types of electromagnetic radiation here. And you can do the same thing with the different relationships between energy, wavelength, and frequency. then you can answer any question that you'll see in introductory chemistry. If you can do this, then you got all of them down. You got every question. I'll give you an example of that in just a second.